Alright guys, we're still on 3.3. This is still part 1, but video 2. Just a little bit left to go on this. We're going to start off with a definition. Alright. This definition is dealing with the number of times a zero happens, or a number of times a zero is a solution to a function. Well, we've seen this before, but let's put it in words now. If a factor x minus c occurs m times in the factorization of f of x, then we say c is a zero of multiplicity m. Alright, so it's the definition here is a zero of multiplicity m. Alright, so a quick example of that is this. Let's say f of x equals x cubed plus x squared minus 5x plus 3. Well, this factors into x plus 3 times x minus 1 times x minus 1, which is obviously the same thing as x plus 3 times x minus 1 squared. So based on this definition, we know our zeros are -3 and +1. But -3 is a zero multiplicity 1. So multiplicity 1. But 1 is a multiplicity of 2. It happens twice. Right? So that's all this definition is saying. Multiplicity 1 on the -3. Multiplicity 2 on the -1. Now how do we show that? How do we show that on the graph? Well, here's the general rule. If m is odd, then the graph, we don't necessarily have to have a particular graph. Let's just say we have the x-intercept c, and we know the graph is going to go through that point c if m is odd. So here the graph goes through c. But if m is even, then we know that the graph, no matter where c is, the graph is only going to touch that point. It's not going to go through it. So up here it went through the point c. Down here, the graph only touches c. So that's the difference. So here, if we were to put this on a graph, we would know it went through the point -3, but it only touched +1. So we'll look at an example of a graph next here. Alright, but it's nothing too tricky there. It's another tool to help us graph things without actually having to plot a ton of points. So let's look at an example of how we would use this in practical terms. Well, let's see. Find the zeros. State the multiplicity. And sketch. Here's our function. F of x equals 1/16 times x minus 2, x minus 4 cubed, x plus 1 squared. Alright, so what are our zeros? Well, the zeros are 2, 4, and -1. But next thing we need to know is the multiplicity. Well, the multiplicity of 2 is just 1. The multiplicity of 4 is 3. and the multiplicity of negative 1 is 2. Recognize that we have f of x has degree 6, right? 3 and 2 is 5, 1 is 6. Well, we have that same number of zeros, right? So that's one way to check whether or not we've done that right up to that point. Next thing we'll do is try to sketch the graph. Recognize it's not going to be an exact graph, but we still can sketch it. Another piece of information that will help us sketch is, of course, the y-intercept. Plugging 0 in for x and working it out, the y-intercept comes out to 8. Okay? So let's try to sketch this. We've got a negative 1, a positive 2, and a positive 4. We know these are our zeros. Now, go back over here. If m is odd, we know that the graph has to go through that point. If m is even, it only touches that point. So let's start with negative 1. Well, at negative 1, we have multiplicity that's even. So we know it's only going to touch the point at negative 1 and not go through. Now, if we want to know whether the function starts up here or down here, we saw in lesson 3.2, I believe, or 3.1, how to do that. So I'm just going to plug negative 2 in up here. If you work it out, it's going to give you a positive y value. So we know the function's coming down like this. It's going to touch the x-axis at negative 1, but it's not going to go through it. It's going to bounce back up and go through this y-intercept of 8. So it'll touch, it'll come back up, it'll go through it. But now let's look at our next 0. Our next 0 is 2, multiplicity 1. Well, our rule tells us m is odd, so it has to go through that point. So it's going to come up here, go through the y-intercept of 8. It's going to go back through your 0 at 2. Our next 0 is at 4, and it's also odd. So again, our rule tells us that the function has to go through 4, so it'll come back up like this. This is obviously a rough sketch, but what you can find is you can use it to find your mins and your maxes, and it gives you a ballpark figure without plotting a bunch of points. So that's kind of how we're going to use these rules that we've been given in the first 2 videos of 3.3. Alright, we'll cut that off here. We'll do some work on these problems tomorrow, and then we'll pick up on Tuesday. Alright?